Imagine a planet entirely covered in ice, with eutropic poles as far as the eye can see, vast stretches of pristine snow everywhere on the horizon, and enormous glaciers. On this world, completely frozen by the cold, no rivers flow and it never rains. Here, even the surface of the oceans, several kilometers thick, has ended up freezing. These landscapes of white desolation don't come straight out of a wild science fiction novel. They also don't describe a planet located at the other end of our galaxy. They happened here, on ours, on the world you live in, and they remained in place for several tens of millions of years. This episode will tell you the story of the appearance and then the disappearance of this infernal winter. Welcome to the Cryogenian, the Super Ice Age. We are about 700,000 years ago, and seen from space, the Earth, wrapped in a thick layer of frost, all in shades of grey and white, looks like a snowball. On the surface, it's 510 million square kilometers of ice, the same planet, but definitely another world, only broken in places by vast and high mountain ranges, from which enormous glaciers flow. On the ground, the average temperature of this frozen world is about 50 degrees lower than it is today. At most, at the equator, is it able for a few hours to rise above zero when the sun is at its zenith? But when night falls on this lethargic world, the thermometer drops to around 30 degrees in the tropics and surely below 130 at the poles. On the surface of this frozen desert, there is no sound of life. Only the sound of ice fracturing below, and the wind that, in the tropics, howls constantly, where temperature variations create and continually renew powerful storms, lifting the snow accumulated on the ground. In this breathtaking scene, where the air is as dry as it is unbreathable, there is no sign of life on the horizon, nothing but death and desolation. Nearly half of the ocean's water is estimated to be frozen at that time. How did the world, in those distant times, end up in the grip of a total global glaciation? And above all, how did life manage to survive during this white hell? And how did the planet get out of this snowy quagmire? To understand what happened, we'll need to go back even further in time. The story begins about 800 million years ago with the breakup of a supercontinent. This supercontinent, called Rodinia, was centered on the equator and brought together all the land masses on the planet. On its surface, there were only deserts of rock, sand, or high-altitude ice, deserts stretching for thousands of kilometers, covering all the land on Earth. Only the whisper of the wind and a few rare occasional showers break this mineral silence. At that time, there was no form of life on the planet in the open air. All living things were microscopic in size and lived only in the oceans. The climate of that time is relatively mild, but that will soon change. Because by breaking apart at the equator, the giant landmass, the continent Rodinia, will trigger the conditions that will lead to the white apocalypse. In just a few million years, the rearrangement of the pieces of the great tectonic puzzle will redistribute the map of precipitation. The immense newly formed sea arms at the equator cause humidity to skyrocket in these regions, and it starts to rain heavily. The increase in erosion from rivers and rainfall greatly disrupts the carbonate-silicate cycle, which plays a crucial role in regulating the long-term climate. Gradually, the greenhouse gas, which is carbon dioxide present in the air, is removed from the atmosphere. Dissolved in rainwater, it contributes, through chemical reactions, to leaching and weathering surface rocks, before running off into the ocean, where it will, by precipitating as carbonate, become trapped in the sediments. By removing large amounts of greenhouse gases from the atmosphere in this way, these impressive phases of erosion will cause the average global temperature to drop, and at high latitudes, polar ice caps begin to form. Usually, when this type of phenomenon occurs, the increase in ice cover helps to dampen the extent of the cooling by reducing rainfall, and therefore the weathering reactions. Rocks, and therefore the amount of carbon monoxide, too removed from the atmosphere. But during the Cryogenian, the thermometer found itself on a slippery slope, dragged down by its own fall. And if the climate started to deteriorate towards ice, it's largely the fault of fire. Because the breakup of Rodinia, by weakening the Earth's crust, would trigger gigantic volcanic eruptions, which rising up from the depths of the Earth will spew out onto the surface. Phenomenal amounts of lava, enough to cover an area twice the size of mainland France with basaltic rocks. The remains of these cataclysmic eruptions are still visible today in the Canadian Arctic. where we find more than 1 million square kilometers of these stacked lava layers. By blasting plumes of ash rich in sulfur dioxide all the way into the stratosphere, reflecting solar radiation, these cataclysmic eruptions triggered a colossal volcanic winter in their wake. While under the black ash-filled sky, large amounts of freshly formed rocks accumulate. Basalt, which absorbs carbon monoxide nearly 8 times faster than granite does. And these two combined effects dealt a fatal blow to Earth's thermostat. The climate system then seems to be caught in a vicious cycle. The ever lower temperatures lead to the formation of more and more ice. The presence of this ice, by reflecting even more sunlight back into space than the dark, absorbing surfaces of land or ocean, leads to even greater cooling, which causes the formation of more ice. Which in turn, well, you get the idea. It takes the form of a slippery slope, an inexorable drop in temperature. Because once the ice passes 30 degrees latitude, which is around New Orleans or Delhi, the world reaches a point of no return. And the polar ice caps began to inexorably advance toward the equator. And in the space of a few centuries to a few millennia at most, which is just a blink of an eye in geological time, the average temperature on Earth drops by about 50 degrees and the planet finds itself completely trapped in the grip of ice. The frozen prison has closed in. It will remain in place for nearly 58 million years until the climate finds the key to unlock it again. And from then on, the question arises, if Earth is not a giant snowball today, what got us out of that white hell? To completely thaw the surface of a world, you need a lot of energy. And to find it, you might be tempted to turn to the one who emits the most nearby, namely our Sun. Except that calculations show that to get Earth out of such a global glaciation, our star would have had to be at least 1.5 times brighter than it is today. Yet, we know that at that time, the Sun, still young, was about 7% less powerful than it is now. In fact, our planet will break free from this frozen prison on its own, with only the help of its own internal heat. Occasionally, as tectonic plates shift and surface weaknesses appear, volcanoes continue to erupt, releasing the excess internal heat of our planet, but also, and most importantly, large amounts of greenhouse gases. And while the infernal temperature of lava is ultimately unable to fight against the planet-wide cold in the long run, the greenhouse gases, cut off by the ice cover from almost all contact with the oceans or rocks with which they could bond, relentlessly accumulate in the atmosphere for nearly 58 million years. The temperature rises very slowly until carbon dioxide levels become 350 times higher than what we know today. From then on, this massive greenhouse effect becomes strong enough to trigger a sudden and violent meltdown. The skyrocketing carbon monoxide, 2 levels eventually break through the ice ceiling. Starting at the equator, where vast stretches of open water and land are now exposed to daylight. Darker than the surrounding ice, these areas absorb more energy from the sun, so the temperature rises even further. This is the beginning of the Great Runaway Effect. The reverse process has begun, and in just a few millennia at most, it tears away ever larger stretches of open water, as well as vast areas of land. Freed from the grip of winter, the world breaks free and shatters the ice for good. It will have remained in place for dizzyingly long periods of time, comparable to the time that separates us from the extinction of the dinosaurs. Once completely rid of its snow mantle, the Earth finds itself, for a time, in a true greenhouse effect from hell. To the point that it's believed that at the equator, surface liquid water must have reached temperatures of nearly 50 degrees. For several centuries, in a scorching, turbulent atmosphere saturated with water vapor, storms and cyclones from another era rage continuously. It is believed that it will take nearly 1 million years for the rocks of the continents to absorb enough of the carbon monoxide, too present in the atmosphere to bring the average global temperature back down to reasonable values. As a result, after about 10 million years of relatively mild climate, the Earth fell back into its old ways with the return of a great winter. Winter is coming back, and this time it will last for about 15 million years. As impressive as they are in scale and duration, these two glaciations are relatively insignificant compared to the very first snowball Earth, and it was also the longest in its history. A total glacial period of a colossal kind which took place in an even more distant past. But the most amazing thing about all this is probably to think that, from the point of view of life as a whole, the last 2 episodes of Snowball Earth may have been, paradoxically, beneficial. By contributing to greater diversity among living beings, to survive these millions of years of total glaciation, to escape the biting cold from all sides, it's believed that living beings managed to take refuge in the last habitable corners of the world, the Ove. Around rare geothermal sources, life took advantage of the heat from volcanic activity. Then the depths of our planet would, in some places, temporarily melt the ice cover at the edges of the continents. There, where the pack ice, battered by tides and the swell of the underlying liquid oceans, ends up tearing to form deep crevasses, gashes that let a bit of light reach the bottom and bring the atmosphere and the sea into contact. On land, tucked at the base of translucent glaciers that light can penetrate, and where the extraordinary thickness causes the ice to melt, sliding over the rocky ground, or at times perhaps on the surface, at the warmest latitudes, or on the continents, thanks to the presence of dark rocks that efficiently absorb the sun's heat. There, small scattered holes can exceptionally form in the ice, temporary melt ponds. Or, more simply, at the equator, directly beneath a fractured ice sheet that is thin enough in places to let the sun's rays reach down. Perhaps exceptionally, there was an open ice sheet there, with a few strips of open water, momentarily giving the inhabitants access to the atmosphere. Prisoners of these oceans, which were then nearly twice as salty as they are today. Each of these possible refuges surely formed small oases for the living beings of that time. And life, including photosynthetic life, apparently emerged from it stronger, more diverse, and sharper than it was before, by pushing the limits considerably before the 2 great glaciations of the Cryogenian. Our planet was inhabited by miniature and relatively little diversified organisms, mainly algae, microscopic primitive unicellular animals, and photosynthetic bacteria. But after the meltdown, we observed that multicellular life forms, made up of an accumulation of differentiated cells, begin to become much more numerous and diverse. The size and complexity of living beings then increased considerably, and many species even seem to have adapted perfectly at the time to these terrible conditions, as if paradoxically, by isolating ecosystems from each other and creating the conditions for strong selective pressure, this cold snap acted like a whip on living beings. Red, gray, orange, blue, or white, the surface of our world has seen all kinds of colors, painted over 4.5 billion years of a long, tumultuous, and eventful history. The traces left by these glaciations have been found, imprinted in the geological layers dating from that other time. All over the world, the rocks that have reached us are marked by the work of glacial sand, which, as the glaciers slid over them, scratched them forever. Sometimes we also find deposits of alluvium left by the passage of these giants of ice, as well as astonishing drop stones, huge stones that, in those distant times, were carried by drifting ice before it melted and suddenly released them from the surface. Flowing at high speed, these stones then plunged violently into the sediments of lakes or oceans beneath them, before reaching us and whispering to us. These places have been, here and there beneath our feet, astonishing elsewheres, simply located somewhere else in time. And even if none of these landscapes, now all turned to dust, were ever seen by a human being, we have been able to give them names, to anchor them in our imagination. And the past has become, in our minds, a great number of other planets. To help us power this channel, you can support us on Utip or Typee.